Moving on to step 3. This is a very important part of the argument. Paraphrasing and common argument patterns. So we know the premises and the conclusions. So we know what the final conclusion is, and we've also identified any intermediate conclusions. But we still need to answer the question, how do the premises support the conclusion? And we know the explicit premises in the passage, right? The ones that the author actually put in there. But are there any implicit premises? Are there any premises that kind of the argument needs to work, but the author didn't include? That very often happens. Step 3 answers these questions by fitting step 2's results into a common argument pattern. Okay, so once you finish step 2, you have the basic materials that you're going to use to sort of create the argument. And you want to take those basic materials and you want to fit them into a common argument pattern. So that's what you're doing in step 3. By doing this, by fitting it into the common argument pattern, you're going to answer the question 1 above. How do the premises support the conclusion? Well, if you fit the premises into a common argument pattern, you can see that the argument is valid. And that means that if the premises are true, the conclusion is necessarily true. So fitting your raw materials, your premises and your conclusions into a common argument pattern answers question 1. And it also answers question 2, right? Because when you fit the premises into a common argument pattern, you often realize that there are premises missing, that you need another premise. You need to make another implicit premise explicit for the argument to work. Now, I'm going to talk about some common argument patterns. The most common one that you use when you're reconstructing arguments is the modus ponens. Modus ponens looks like this. If P, then Q. P, therefore Q. Now, to fit a passage into the modus ponens, you take 2 declarative sentences from step 2 and you map them onto P and Q. So for example, from the Augustine passage, map one statement, I can be mistaken about my existence, onto P, and map the other statement, I exist, onto Q, and that will yield this. If I can be mistaken about my own existence, then I exist. As soon as you have that relationship between P and Q, if P then Q, you can create a modus ponens. If I can be mistaken about my own existence, then I exist. I can be mistaken about my own existence. Therefore, I exist. So that's how a modus ponens works. It's a logically valid argument. If the premises are true, the conclusion is necessarily true as well. Okay, the reason why we said that the modus ponens argument pattern is the most common argument pattern is because you could fit basically any passage into the form of a modus ponens. Here's what I mean by that. So you can take any argument in standard form. So you've taken a passage and you've identified all the premises and you've identified the conclusion. And that's your raw material that you're going to fit into the modus ponens. So you have 3 premises and the author is arguing that they all lead necessarily to your conclusion. So you're going to take them and put them into a modus ponens argument. And this is how you do it. So the first premise of your argument is going to be a conditional where you say, if first premise, second premise, and third premise, then conclusion. So this is going to be an implicit premise in step 2, right? So in step 2, when you identified the raw materials, all the premises and conclusion, this one wasn't in there because the author didn't structure it as a modus ponens. So you're taking that raw material and you're fitting it into a modus ponens pattern. So this premise would be an implicit premise in step 2. And in step 3, where you're fitting the argument to a pattern, you're making it explicit. This can be awkward if you have a lot of premises. So if you have 6 premises that lead to a conclusion, it can be extremely awkward to construct a modus ponens out of it. But it's still valid, right? It's still a valid logical form. So you can still do it if you want to. This will be your best friend when you're reconstructing arguments and you need a fallback that's safe, reconstruct it as a modus ponens. It's called NPing it. So it's such a common strategy when reconstructing arguments that there's actually a verb for this activity. It's called NPing. So if you run into a wall and you can't figure out how to reconstruct an argument, tell yourself, just NP it. Here's an example using the first half of the basic necessity argument we looked at. Everybody deserves life, liberty, and the pursuit of happiness. Therefore, everybody deserves basic necessities. So those are 2 statements that were available to you after you did step 2 and you've identified the raw materials of the argument. Now you can NP it, take them both and put them into the first premise of a modus ponens. If everybody deserves life, liberty, and the pursuit of happiness, then everybody deserves basic necessities. Everybody deserves life, liberty, and the pursuit of happiness. Therefore, everybody deserves basic necessities. And that means, like, so later on, when you're sort of, say you're trying to justify or defend this argument, it's going to be really crucial for you to justify that link between P and Q. In this case, you're going to have to justify that link between everybody deserving life, liberty, pursuit, and the pursuit of happiness, and then everybody deserving basic necessities. You're going to have to show that there's a real connection, a real link between getting basic necessities and enjoying life, liberty, and the pursuit of happiness. Okay, so MPing your premises that you and your conclusion that you identify in step 2, that should be your default strategy for step 3. It's the easiest way to do it. But you can depart from the default under certain circumstances, and with practice, you'll know when to depart from it. So sometimes you'll want to use a modus tollens. So that's the kind of cousin or, you know, an evil twin of the modus ponens. It basically flips the modus ponens. And the modus tollens goes like this. It has the same first premise as the modus ponens. It says if P, then Q. And then instead of affirming P, right, instead of affirming the antecedent, which is what the modus ponens does, the modus tollens denies Q. It denies the consequent. So it says if P, then Q. It's not the case that Q, therefore it's not the case that P. And that's another valid argument form. And you can see how it's just flipping the modus ponens. If it's the case that every time you have a P, you also have a Q, then if you don't have a Q, you know that you don't have a P. Pretty intuitive, I think, and it's a very common argument form. So here's a famous example. This is Moore's response to Descartes' dreaming argument. So Descartes' dreaming argument in the second meditation, I believe, he says, if I don't know that I'm not dreaming, I don't know that my hands are real. And then Descartes uses this as a modus ponens, and he says, I don't know that I'm not dreaming, therefore, I don't know that my hands are real. But then G.E. Moore flips this, and he says, instead of doing a modus ponens, he does a modus tollens. He says, I know my hands are real, which is very intuitive. It's very intuitive that my hands are real. Therefore, I know I'm not dreaming. So this is called Moore's flip, and it's one of the more famous modus tollens arguments. And all he's doing, he's denying the consequent, which allows him to deny the antecedent too. So he denies Q, and that allows him to deny P. Another common argument form, one that you might find useful, is the disjunctive syllogism. It goes like this: either P or Q. It is not the case that Q, therefore P. The form for 3 options would be either P or Q or R, and then you eliminate the other 2, and then therefore only P is left. So you can expand this to 4 to 5 different things, but usually you don't want to go beyond that. Another sometimes helpful argument form is the hypothetical syllogism. So this is a syllogism that consists only of if-then statements. So the MP default doesn't work well when your conclusion is also a conditional. So you can do this instead: if P, then Q, if Q, then R, therefore if P, then R. Another argument form that's useful is universal instantiation, right? So this one starts, the first premise is a universal principle, all F's are G's. Second premise is A is an F, therefore A is a G. And that's very intuitive too. If all F's are G's and A is an F, then A's got to be a G as well. So A usually refers to an individual person, place, or thing, and F and G refer to properties. So here's an example. This comes from Donald Davidson. Every event that falls under a physical law has a physical description. The mental event M falls under a physical law. Therefore, the mental event M has a physical description. Okay, so that's basically all I wanted to say about step 3. You take the premises and conclusion, the raw materials that you discovered in step 2, and you fit them into a common argument pattern. And by doing that, you show how the premises support the conclusion, because once you fit it to a common argument pattern, you know that if the premises are true, then the conclusion is necessarily true. And also fitting the raw materials into a common argument pattern will often make implicit premises explicit. So we saw that, for example, in the case of the modus ponens. If you reconstruct a simple argument as a modus ponens, you know that the conclusion necessarily follows from the premises, but that premise, that linking premise, might not have appeared in the original argument. So it functioned as an implicit premise. So now moving on to the final step. At this point in your reconstruction, you know that you have a valid argument. If the premises are true, then the conclusion is necessarily true. So the next thing to do is to ask, are the premises true?